Welcome to the very first video of an exciting new series where we will build an entire to-do application step by step that includes provider for state management, REST API integration, filtering, proper error handling, and much more. By the end of this series, you will know exactly how different parts of the Flutter application work together, not just how to build the screens. So let's see what we are building. Alright, here is the Finish app running in the simulator. The first screen user see is the to-do screen. At the top, we greet the user based on the time of the day. Below that, we have a statistics card showing total to-dos, incomplete to-dos, completed to-dos, and overdue to-dos. These values aren't hard-coded. They are calculated automatically whenever to-dos change. So, as we add, complete, or delete to-dos, these statistics update instantly. That gives user a quick overview of their workload. Alright, below the statistics, we have our list of to-dos. Each to-do contains title, description, category, priority, due date, and reminder date if we have set one. These cards are clean and easy to scan. We can also visually distinguish between categories and priorities using icons and colors. Next, let's complete one to-do. Notice how immediately the statistics update. The completed count increases and incomplete count decreases. No refresh button, no rebuild in the page manually. Everything updates automatically. Next, let's create a new to-do. For that purpose, click on this floating action button. Here, user can enter title, description, category, priority, due date, and reminder date. We will also perform proper validation before submitting the data to the server. Now, let's create a new to-do. Let's add some description, select the category as work, priority as high, and set the due date as maybe 11th of July. Hit save. Once saved, the to-do is sent to our backend API, stored in MySQL, and automatically appears in the list. Next, editing is equally simple. Just tap on the edit icon. All the existing values are pre-filled. For example, let's change the priority to medium. Hit save. And once the process is completed, the changes are immediately reflected in the list. Next, deleting a to-do is also safe. Just swipe left on any to-do, you get the delete action. And instead of deleting immediately, we first show a confirmation dialog. This prevents the accidental deletion and provides much better user experience. And if user hit delete, then the to-do is deleted from the list. Next, suppose you have a large list of to-dos. In that case, finding the right one becomes difficult. And this is where the filter feature comes in play. User can filter to-dos by category and priority. For example, let's select category as health and priority as high. Notice the list updates live as you select. And if you want to clear the filter, just click on the clear filters button at the top. Now let's talk about the settings screen. Clean, group, and purposeful. Under the appearance section, we have the dark mode toggle. Right now, we are in the light mode. Watch what happens when I flip it. Instantly, the entire app theme changes to dark. No restart, no flicker. And that preference is persisted with share preferences. So the next time you open up the app, it remembers your choice. Next, under to-do display, we have show completed to-dos toggle. Right now, it's on. So if I go to the to-do screen, we can still see the completed to-dos in the list. Let's go back to the settings screen and toggle it off. Now, if I go to the to-do screen, the completed items disappear from the list. Great for keeping your view focused on what still needs to be done. Let's go back to the settings screen and under About, we have the app version. Tap on it and a beautiful dialog appears with Flutter logo, app name, app version, and a clean description. Polished and professional. Now let's talk about the backend. This application isn't using fake JSON. It talks to a real backend. I have built the backend using ASP.NET Core running locally, and all to-do data is stored inside a MySQL database. So whenever I create, update, delete, or fetch to-dos, Flutter communicates through the REST API like a real production application. Now don't worry if you don't know about ASP.NET Core. This series is completely focused on Flutter. The backend is already prepared so we can concentrate on learning Flutter concepts without getting distracted by backend implementation details. Next, to interact with our API, we will be using Scalar. Scalar is a modern API reference tool that makes working with REST API much more enjoyable. Instead of digging through the documentation, you can get a beautiful interface where you can explore all the endpoints like get, post, put, delete. And you can even test them right here in the browser. For example, let's click on API/todos. It's a GET request. And let's click on test request button and hit send. And there is our data coming straight out of MySQL, formatted beautifully. And that's the exact JSON our Flutter app will consume. Throughout this series, we will be using Scalar whenever we need to understand an API endpoint before integrating it into the Flutter. That makes the API integration process much easier, especially for beginners. Alright, backend is running. Now let's look at the Flutter starter project. Instead of starting with a completely empty Flutter project, I have prepared a starter application so that we can focus on building the feature rather than spending time on repetitive setup. Let me quickly walk you through what's already in place. Under the lib folder, I have created an src folder, and inside that we have core folder. This will hold up our App-Void constant, utility functions, and helper classes that don't belong anywhere else. Next, we have models folder, our data classes. This is where our to-do model is going to live. Next, we have providers folder. This is where provider lives, our state management layer that keeps the entire app in sync. Next, we have the screens folder, which will hold the UI for our screens. Next, we have the services folder. All the HTTP communication with our ASP.NET Core API goes here. Next, we have the themes folder, which will hold everything related to the application's light and dark themes. And lastly, we have the widgets folder, which will hold the reusable UI components. Next, let's open up pubspec.yaml file and let's go to the dependencies section. And these are the key packages that we will be using. Provider for state management, HTTP for communicating with our REST API, INTL for formatting date and time, and shared preferences for storing user settings like dark mode. Before we run the application, there is one more thing I would like to point out. Let's open up the analysisoptions.yml file. I have also configured a few formatting and linting rules for this project. These rules help keep the codebase clean, consistent, and easier to maintain. And finally, let's run the application. And as you can see, there is not much here yet, and that's completely intentional. We are currently having only two simple screens, to-do screen with just a title and setting screen with just a title. And this is our blank canvas. Over the next few videos, we will transform these empty screens into a fully featured to-do application you saw at the beginning of this video, step by step, writing every important piece of code together. And that's it for this video. I have added the link for the starter project and the backend project in the video description. So go ahead and clone the repository, open it in your favorite IDE and get everything ready. In the next video, we will start by creating our to-do model, which will become the foundation of everything we build throughout this series. Thank you for watching this video, and I will see you in the next one. Happy coding!